This tutorial is all about completing the square, why, and how. Alright, so let's start with the first question, why? Right, consider the expression that is written in front of you. Alright, if you were to try and factorize it, let's say this is your quadratic equation, your parabolic function, and you want to find the roots. Alright, you want to do your factorization so that you can find the roots. Right, how would you do that? So let's say you manage to get to this point where that is equal to 0. So when factorizing, you consider the first, right, the x squared term and the last term, which is the constant. Right, so what you will do to factorize, you will say, okay, let me see if I can find the middle term. So you have x squared, which is going to be formed by x times x, and then you take the last term, which is a constant. Its prime factors here, there will be 3 times 1. Okay, so let's just say maybe you realize, okay, 4 is a negative, so let me try and see. I must give the negative to the bigger number, so that negative 3 times 1 will give back your negative 3. Alright, so now what you will do is you'll then multiply these numbers with each other. So you'll then multiply that with that. You will get minus 3x. If you multiply that with that, you will get a positive x. Right, all of that together will give you a negative 2x, which means this is the highest possible negative number that you can get, right? And you want this number to be equivalent to the middle term, right? But in this case, it is not. So that already should tell you that this number or this expression is not factorizable, right? So the reason we complete the square is for expressions like this that are not factorizable by whole numbers. Not that it's totally not factorizable, but you cannot do it with whole numbers. All right, so we have answered why we complete the square, right? Because there are expressions that are not factorizable by whole numbers. They're probably irrational values or roots that we are going to find. So then we apply what we call completing the square. Now we're going to ask, how do we complete the square? Right, good question. Okay, so now with completing the square, so a parabolic function or a quadratic equation has a general expression of ax squared plus bx plus c. All right, so consider that you have this expression and it's equated to 0, so that when you factorize it, you can find the roots, all right, or the values of x. Now, completing the square, you have to start by dividing by the coefficient of the x squared term. So then how do you, so you will have to say, okay, divide by a first, all right, before you can start doing anything. So you divide by the coefficient of the x squared term. So you divide the whole expression. Then once you are done, okay, so here this will cancel with that. All right, and then you will now be having x squared plus bx over a plus c over a, and then this is equals to obviously 0. Now, before you complete the square, you want the constant part to go to the other side. So you take this to the other side. And then when you take that to the other side, it's going to become a negative. So remember, we haven't started any completing of the square. So we are just doing the prerequisite before we start. Right, so then you'll have x squared, and that's what you want. You want to have that x squared term alone, and then plus bx over a, and this is going to be equal to negative c over a. Now the next thing is, all right, so once you have done that, you are going to add both sides. You're going to add, okay, so now you start with yours. So on this step, you're going to say to add half of the coefficient, okay, coefficient of x okay, then square it, okay, then square it, right, both sides, okay. So which means you're gonna have x squared plus bx over a. Then the coefficient of the x term is b over a. So in that case, you are going to have, say, plus that b over a with its sign. So it's going to be into, so it's going to be half, all right, of time your coefficient b over a, and all of that squared. And you do that both sides. Right, on the other side, you're going to do the same thing. Add that. Then that squared minus c over a. Let's do this so that we don't mix all of this, and then it's now the way it's looking like it's related. So I'm going to take that out from there. Okay, there we go. So now you have that. Then now, so this is what we added. We added both sides, and we are not doing anything wrong by doing this, because we could have simply, okay, we could have simply take this to this side, right? It becomes a negative and it cancels with that. So we are not changing the expression by doing that, right? We are still haven't changed the equations to the same. Right, then afterwards, obviously you get your results, x squared plus b over a x. Then you've got plus, right, into b over 2a squared, right, which is equals to also b over 2a squared minus c over a. All right, so now here I'm going to rewrite that, okay, as x squared. All right. So now on this step, right, you are going to take, okay, when you reach that step and you did it like that, all right, so on the left hand side, take the numbers, or rather the expressions, take the terms inside the brackets, inside the bracket, inside the brackets, then place them in the same bracket. Same bracket. So what do I mean by that? So you're going to take that and that, right? Place them in the same bracket. So you're going to have x plus b over 2a, and then afterwards, then you what? Then square them. Right, so you're going to square them like that. Right, that's the aim. And then on the other side, you're going to simplify. So b over 2a, all of that squared, is going to result into b squared all over 4a squared minus c over a. Right, so what's going to happen is that you're going to now take square root both sides. So that's what's going to happen now. Take a square root both sides. Okay, and then on the other side, I'm just going to move it a little bit so that we can see what's going on. Then you also, that side, you're going to take square root, but you're going to say plus minus, because every time you take a square root, you need to put the plus minus. So you do like that. And then over this side, obviously the square is going to cancel with the whole root there. So you're going to be left with x plus b over 2a, and all of that equals to plus minus root, okay, root of b squared all over 4a squared minus c over a. Right, so now we want to simplify what's in the bracket there. So what we will do is we will have everything have the common denominator. Right, so common denominator for what's in the brackets, obviously you're going to say, okay, what terms do you have in there? So find the LCM. You've got 4a squared and a, right? So for both of them, you're going to write the numbers you have. So you have 4 and you have a. So what is the highest exponent of 4 between these two? Okay, so obviously the number is 4. Highest exponent is obviously the 1. For the 2ax, the a squared and the a, highest exponent is the 2. So it's going to be, so which means this is the LCM. Right, so which means that's going to be, you're going to have now x plus b over 2a. Then this is going to be equals to plus minus, right, square root of, okay, the whole expression now is going to be under a common, so which is 4a squared. Now, if you take the part of b squared over 4a squared, multiply it with 4a squared, that will cancel. You'll be left with b squared minus, then if you take the c over a part multiplied with 4a squared, right, one that a will cancel, will leave c times 4a, which will give you 4ac. 4ac. All right, so that's what you get. And then afterwards, you can take the part of the 4a squared at the bottom. You can take it outside because that's a perfect square. It's because 4a squared, right, can be written as, for example, 2a, all of that squared. So you can take that out. When you take that out of the root, it will just become 2a. So square root of that, think about it, it's actually just 2a. So we take it out. So we'll have x. So I'm also going to take this expression to that side. Right. So we will have x equals to b over 2a plus minus 1 over 2a. Remember that this is coming from underneath there. So it's 1 over. And then inside is going to be square root. Then we're just left with b squared minus 4ac. Then afterwards, this is going to be, you factorize the 2a there, 1 over 2a. So get common, so you basically have 1 over 2a into b. So when it comes that side, I didn't do something I didn't do there. Okay, so you're supposed to have a negative there. So this will be minus b plus minus root of b squared minus 4ac. Okay, minus 4ac. Right, so if we have that, then this can be written as x equals to minus b plus minus square root of b squared minus 4ac, and all of that divided by 2a. Doesn't that look very familiar? Okay, so for all those who don't know, this formula came about because of completing the square. Okay, so let's look at the expression that we had above. Okay, so you can use this as a shortcut of completing the square. So if you want to see if something is factorizable, you take the square root part, and say b squared minus 4ac. So if you put your values in there, all right, and you find that you get a whole number, it means it's factorizable by whole numbers. But then if you do that, you take all of that and realize that it doesn't give you a whole number, right? It doesn't give you whole number. Then quickly you now know that that is not factorizable by whole numbers. You go straight into applying complete the square. So just like our expression, I'm going to show you. Our expression said, okay, x squared minus 4x minus 3. So if I was to take that, so obviously I know that this has a format of ax squared plus bx plus c. So coefficient of x squared is 1, b is a minus 4, so I'm going to have what? B is going to be minus 4 squared minus 4, and then a is a minus 3, okay, and then c is a no, a is a 1 and c is a minus 3. Okay, so let me do it according to that. 1 minus 3. So you're gonna get root of, for example, 16 negative times negative, that's positives, so that's going to be 4 times 1 times 3, that's 12, and that's going to give you positive 28. We all know that 28 is not a perfect square, so because 28 is not a perfect square, so this will not give you a whole number, so not equal to whole number. So immediately we apply completing the square method. So there we go. So which will say, okay, first x squared, then minus 4x, then we take this to the other side, equals to 3, and then we will add this step, then we will add, right, half. We'll take half of the middle term coefficient, square it, and add it both sides. There we go. Then we say plus negative 4 over 2, right, squared. On the other side we'll do the same thing. 3, same thing, square. So, and then I will rewrite that as x squared minus 4x, and then that is going to give plus into minus 2. A lot of you would love to just take that out of the, out of those brackets and simplify it, but in this case, for simplicity's sake, please don't. Right, simplify whatever is in the bracket and leave it like that, simplified in the bracket. And then it's only on the right hand side, right, where there is the constant c, where you simplify everything. So you have 3 into obviously minus 2 squared. So on the right hand side, minus 2 squared is 4, so you simplify the plus 3, then it becomes 7. Okay, on the other side, you're going to take what's in the bracket, put it in the same bracket like that. So x and minus 2, positive x and minus 2, you put them together and you square that. Then the last step, now you're going to take a square root. Okay, so I'm going to put it there. So when you take a square root, on the other side you're going to do the same. It's going to be plus minus, take a square root. Then you are going to have be left on the other side with x minus 2 equals to plus minus root of 7. Then, okay, what is left is just simplifying. So x equals to positive 2 plus minus root of 7. 7 is not a perfect square, so, and that's the reason why we are completing the square in the first place. Okay, so which means x equals to 2 plus root of 7, and again x is equal to 2 minus root of 7. So that's the basics of completing the square. So what if you had some other numbers, like for example you've got 5 x squared minus 15x, and then also minus 5, and then equals to 0 as an example. So how will you deal with that? Like I told you, first thing, because now we have a coefficient of a that is more than 1 here, I mean of x, that is x squared, that is more than 1, so we divide first. Okay, so first thing is divide by the coefficient. So divide, divide, and divide. So the answer is going to be x squared minus 3x and then minus 1 is equals to 0. Then you can now complete the square. So you take that part, that other side, so you're left with x squared minus 3x equals to positive 1. The next, right, you're going to say x squared minus 3x. Then you are going to, right, so you have 1 there. You're going to add, right, half of that. So, and then you're also going to do the same on the other side, half of that. All right. Then afterwards, you're going to have, I'm going to rewrite this like this. Right, keep that also like that. Then on the right hand side, I'm going to simplify. So this is the same as 1 plus 9 over 4. Okay, then I'm going to take what's in the bracket, put it together, x, and then minus 3 over 2, all of that put together and squared equals to, okay, 1, that obviously is going to be 13 over 4. Right, now I can take square root both sides. Then I can say plus minus square root both sides. Then I will be left with x, right, minus 3 over 2 equals to plus minus, right, square root of 13 over 4. Then you take this to the other side, okay, where it's obviously going to change into a positive. So x is going to be equals to 3 over 2 plus minus root of 13 over 4. Right, which means that x is either equals to 3 over 2 plus root of 13 over 4, and again x is equal to 3 over 2 minus root 13 over 4. And then you're going to get obviously your decimal, so your roots in this case are going to be irrational numbers. All right, so as long as what's inside the root, right, the square root is a positive, right, as long as that's a positive number, right, if you get a negative number inside the square root, it means the roots are non-real. All right, so in this case, the roots are real because what's inside is positive. Okay, because remember, you cannot have the square root of a negative. So basically, that is how to complete the square and the reasons for completing the square. So if you like the video, do give it a like and subscribe to see more videos, and do comment if you prefer specific videos.